Okay, so I think I'll start all of my sessions just by looking at the schedule. So this is the schedule where you can get all of your information for the week. And if you scroll down here, we can see that today is Wednesday, July 28th. And we're in this session here, which is 9 to 11 a.m. GMT, so in Ghana local time. And we can click on that and we can find the name Data Analysis and Visualization Python tutorial, and this is all the information. So I assume you all did this because you all found the right link at the right time. And you can get the link to the Jupyter Hub here, and hopefully all of you have filled out the Google form already. And with that, I can get a list of all of your Google emails and add you to the Jupyter Hub. So when you click on the link to the Jupyter Hub, it should take you here, and you'll click Login to continue, and it will ask you to log in with your Google email address. And then it might take a couple minutes to start, but once it starts, it should look something like this. So hopefully some of this sounds a bit familiar to all of you. This is what we went over in the last two tutorials. But I know we all have different things going on, so if you have any questions, don't hesitate to ask. Okay, so today we're going to be going through this notebook. So I just double click on that, Data Analysis and Visualization. And it opens up in a tab here. So this is a notebook that will take us through how to load CSV files. So many of you, if you do any sort of data analysis, you might have CSV data. That's often how we would store data that we might look in Excel or anything like that. So it's kind of like a spreadsheet kind of data. We call it tabular data. And it's in kind of rows and columns. And so we're going to load in CSV data and we're going to make some plots. So I have a lot of, so this is written hopefully so that you can walk through it yourself. So you're welcome to do that and read all of everything here. But I'll be walking through it today as well. So you can stop and ask questions anytime. And you're all going to be making some plots from data from Canberra, Australia, which is where I'm currently located. So, which might be more fun for me than all of you because you're not here, but hopefully it's still interesting. Okay, so there are a couple things. I made this notebook last year, and actually there are a couple things that are a bit outdated that I didn't update. So this line here that says we always start our scripts with this % matplotlib. Oops, I think I misspelled that anyway. Inline is actually not necessary now. So you can see I still have it here, but I put this hashtag, which means it's commented out. And that means that it won't be evaluated as Python code. So it's just plain text. And I wrote a little note here, you usually don't need this line anymore, but I left it here in case you do. And you'll know you need it later. If we try and do a plot and it doesn't show up, then you probably need to uncomment this line and run that. But other than that, we normally start at the top of our notebooks by importing the libraries that we need. So in this case, we will be using the Pandas library, which is a very, hello? Was there a question? No. Okay. So the Pandas library is how we're going to load in the CSV file. It's very commonly used in data science these days and in a lot of scientific disciplines as well. And it's just a really nice way to organize the data and load it in really quickly and work with CSV type data. So that's going to be one of the highlights that we'll be using. For plotting, we use this package called, oh, sorry, maybe I should zoom in. Is that better? Called matplotlib.pyplot. And that's the plotting library that we're going to use. And we import that. We import all of these with kind of shorter names, and you'll see why once we start using them. We use NumPy, so that's numerical Python. And these are all very commonly used packages, and they're all included in Anaconda if you download that to your computer. And this last one here is one that you don't really need, but it's sometimes when you evaluate some Python code, you'll get a little warning and it'll be highlighted in red and it'll say like, warning, this, it'll have some warning, but it's not actually an error. So it'll still run your code. So if you don't want those warnings, you can import this package and then say warnings.filter warnings ignore, which means it will not tell you the warnings. And so then you don't have to see them. So I've done that here just to try and make it a bit cleaner so you don't have to worry about the warnings. Okay, so we can see here we have these brackets with an empty space in the middle off to the left of the cell. That means that the cell has not been run yet or not been evaluated. So to evaluate it, I have the cell highlighted, and I know it's highlighted because of this blue bar. And then I hold down the shift key and then press enter. You can see that little star and it just turned into a 1. And the 1 means that it evaluated correctly and we didn't get any error messages. So we're good to go. Are there any questions so far? Have I lost anyone yet?
Someone just posted, how do you download Python? I was typing to respond to the person.
Oh, thanks, Joseph. Yeah, I can answer that
Augustine.
quickly.
Okay,
yeah, thanks.
sure.
I just pulled up the chat. I realized I had it hidden behind. Yep, so you can download the Python. You can download Python through Anaconda. That's the suggested way because it comes with a lot of the packages and software like Jupyter that you will probably want. So if I go back over to the schedule, so this is the schedule document that you should all have. If you scroll down to the last page, this is at the very end, there's some useful information. So this is about the Slack workspace. This is about the Jupyter Hub. And at the bottom, it has instructions for downloading and installing Python. So for Dr. Daika Augustin, sorry if I said your name incorrectly, but you can find the information here. So here's the link to the Anaconda install site, and there's some YouTube tutorials that you can watch to see how to do that. Okay, any more questions?
So I would like to ask, are you going to demonstrate the running of this program on the Python platform for us?
So that's what I'm doing right now at the moment. So we're running Python code here from the Jupyter Hub. Is that your question? So I'm sharing my screen. So what you can see here is a notebook that's on the Jupyter Hub that has Python code, and we're running it as we go.
Question?
Yes.
Question? Sorry for my English. How do you know that you need to load this library? I don't know, is based on your experience?
Yes, so that is a very good question. Yes, that is a bit of experience. So this is where it's nice to start with some examples like this. I will say we often use NumPy. That's one that's very common for most mathematical computations. But yeah, it's something often when I start a script, I don't know what packages I'll want. And I go down and then I say, oh, actually, I want to load a CSV file like we do in this next bit. And then I realize, well, I have to use a package to do that. Python doesn't do it. I mean, I have to use a library. And I say, oh yeah, I want the Pandas library to do that. So it is a bit of knowing which libraries can do what. You can also Google, you could say, oh, how to load in CSV in Python. Maybe we should try that. I wonder what it'll do. I feel like it will probably tell us to use Pandas. CSV in Python, let's see. Yeah, so the first one says use Pandas. So that's one way you can do it. You can use Google. Google is your friend, or whatever search engine you use. And say what you want to do and it will usually tell you. So a lot of the packages like these are very commonplace. So you'll start to know, well, if you want to make some basic plots, you want matplotlib.pyplot. It's kind of what we use. Sometimes you'll need a fancier one, like if you want to make maps, and you could use something like Cartopy. And there's the tutorial on that next Monday. So yeah, it is a bit of experience. Yeah, I hope that answers the question. Also, I do want to note that I do speak French. So if you said your English wasn't your first language, if you ever want to ask something in French, let me know. Je peux parler en français.
Okay, thank you. D'accord, d'accord, merci.
Ouais, de rien. Okay, so there are a couple questions here. Yes, everything, my screen now is actually on a Mac computer. So it's using the Mac OS, Mac operating system. So that's not a problem, but it works on Windows and Linux as well. Yes, Zineb, Pandas is basically, it's a package for reading tables, basically. Yeah, so that's when we say tabular data, it's kind of data that can be put into tables. That's a good way to put it. But it also can do a lot more. So it's not just for loading them in, it's for manipulating them and doing calculations and some plotting and stuff like that as well. Yes, Anaconda, yes, it works on any operating system. So you just want to, so if you go back here, if I click here and go to Anaconda, so it says for Mac OS here because it could tell that I'm on a Mac, but you can say get additional installers. This is Windows, this is for Mac, and this is for Linux. So you can choose there. So just make sure you choose the correct one. So with Pandas, so this is Zineb's question in French there. So can you use Pandas as a package to make graphs? So you can kind of, mostly we use this matplotlib.pyplot library to do that, but it does have a native built-in .plot, which actually uses this matplotlib.pyplot library in the background. So you'll find that sometimes where libraries depend on other libraries. So the plotting library is in fact the matplotlib pyplot one, but Pandas has some functions in it that will call that for you. Let's see, so how, this last question here, comment peut-on attacher les tableaux? So I'm actually not quite sure what you mean by attaching the tables. Do you mean like loading them in? So we'll see that actually in a second. So Pandas has a nice way of visualizing the data once we load it in. That'll look like a table. So maybe that will answer your question. These are all good questions. Anything else? Yep.
Let's continue.
Okay. Yeah, great. Thanks everyone for the patience. Okay, so I'll zoom in again. So now we have these libraries imported. Now we want to load in the data. And if you were at one of my last tutorials, you can see here that I have to go into the shared folder, and then I'm loading in this data file that's .csv, which means that it has the variables are separated by commas, so it's comma separated. And so we use pd dot, which means we're accessing the Pandas library. So you notice up here, we said import Pandas as PD. So every time we want to reference a function from the Pandas library, we have to type pd dot and then whatever function we want to use. It seems a bit cumbersome at first, but it's actually really nice because then you know which functions are from which libraries, which really helps. So it's a nice way to keep things organized. And you'll see that almost everyone uses the same shortenings for all of the libraries. So anyway, so we use this read CSV function. So I type shift return and that evaluated. So now we have this data that's called T. So I could actually just, if I just type T, so I put a comment after the T, which means the rest of this that's kind of in green is all just a comment and won't be evaluated. So if I evaluate this cell, then we can see that it shows our data in like a table form. So here's where you can see your data as a table, but you notice that it's a very big data set. So we have these rows. It starts with 0. That's one thing you'll note. In Python, all indices start with 0. It doesn't start with 1. So that's different from something like MATLAB, for instance. So you have row 0, 1, 2, 3, 4. Then you have these ... dots, because then you go all the way up to row 4,403. And so it didn't want to print all of those out. Otherwise, we'd be scrolling down the page for the rest of this tutorial. So it just has these ... dots. So you get to see the beginning and the end of your data. And you see in the columns, they're all labeled. So these would be kind of like the variables in your data set. So in this case, there's kind of a lot of junk. Product, code, doesn't matter, they're all the same. Bureau of Meteorology station number. So this data set, I should have mentioned this, is temperature data from a station from the Bureau of Meteorology in Canberra, Australia. So it has all this information that for us might not be super relevant at the moment, like the station number. It looks like it's all the same station. And it has the year. So notice it starts in 2008 and goes up until 2020. And then we have month and day as well. And then we have the maximum temperature, and it even puts the units there for us in degrees Celsius. And we have these NANs here. So NAN basically means not a number. And it just kind of means like missing values, which often happens with observational data. And Python and Pandas are pretty good at dealing with NANs. That's what I usually call them, as NANs. But sometimes we run into trouble, which we'll actually see later how to deal with that. But anyways, you get into 2020, you can see that here are the maximum temperatures for each of these days. And then you also have some other things here, which we're not going to worry about. So that's how it will look when you evaluate the cell. Guifo, you have an error when evaluating this cell. Did you correctly load in the data in the previous cell? So this is one thing actually that's useful, is knowing how to read error messages. So especially if you want to ask for help, if you say, oh, I got an error, that's not super helpful for me or someone who could help. But saying what the error is helpful. So we could actually make an error. Let's just say I double typed a P. So I have PDD dot, and then I try to evaluate this cell. So then I get an error and it looks like this, and it says name error colon, and then it tells me what's wrong. So it says name PDD is not defined. And that's when I should look at it and go, oh yeah, I defined it as PD, not PDD. And then I can go in and delete it. So if you get errors, usually the last line is the most helpful, but you also noticed this line here has an arrow to the line that causes the problem. When it's just one line, it's pretty easy. But if I had 10 lines of code in this cell, this arrow would point to the line that has the error in it. So, okay. So my guess is that there's something typed wrong in this cell, which is interesting because it should be the same as what I have here, but maybe you accidentally typed something different. And if you get errors like this and you can't figure them out, a screenshot is really helpful. You could post something on the Slack group, and there are quite a few people here, people like Joseph, who's quite familiar with programming. There are several of us who could help, but screenshots are really useful. Okay, I'm gonna reevaluate that so we get rid of that error. Okay.
Hello.
Yes.
Hello.
Yeah. Jen?
Yes. Please, if I try to read in data, does it mean that anytime I use the double dots, the code will know that it's referring to my the folder where I want to import the data from?
That's a good question. So the double dot means that you're going back one folder.
Okay.
So yeah, so that's a very good question. So if we go back up here, we have this, this is the path. We're actually in a folder now called COESSING2021 Hub. you can click back on the home folder and you see that there's shared. So I actually, the dot dot means go back one and then go into the shared folder. That was a very good question. Was that clear?
Oh, okay. So if I use it locally, depending on the number of folders I have to go back to access, determines the number of dots.
Yes. So if the data is in the same folder, then you don't need any dots. But every time you do dot dot, it goes back one. So if you have your data stored 5 folders back or something, then you just do like dot 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 dot. At that point, it might be easier to just put the whole path name in, which I could do here as well. I didn't do it because the name of our home here is a bit confusing. They have it called Jovian, and I didn't want to confuse people with a different name.
Okay.
But in your own computer, putting a full path name can be quite useful. And then if you move something around, well, I guess if it's a path name, it's still, but anyway, if you move some folder around and it doesn't go back one anymore, then, that could break.
Okay, thank you.
Okay, I see the question, practical reference for beginning Python. So hopefully you can kind of follow along with what I'm doing here, but I agree that it's really good to have some background. So if you go to the COESSING website and go to the resources tab here, you scroll down, it has Python and Jupyter Notebook resources. So these top ones are kind of how to install things. And these are documents that I put together from previous years. But there's lots of really, I say here, good websites with a lot of resources. And so a lot of these are really good for learning. And I have little notes of what each of these have. So that's where I would direct you to. Okay, I'm going to continue unless there are more questions. So before here, I had t.head. So I'm going to do that again. And what that does is it just prints the first 5 rows of our data frame. So we don't have all these dot, dot, dots. So I can just say t.head, and then we just see the top 5 rows. I usually do that because often you have a lot of data, a lot of rows, and all you really want to see is how it's laid out and what the different columns are. So I use this .head quite a lot. Sorry, I was getting some feedback there. And you need this, the .head is actually, so this head is actually a function, and that's why you need these parentheses. So a function has parentheses, but you don't have to put, it doesn't take any input. So that's why it's a parentheses with nothing in it. So you'll see that a lot in Python, but it won't work if you don't, I don't think it'll work. So if I do it without, so it actually doesn't error. So it can still do it, but it doesn't give you the nice structure that you want. So if I do the parentheses, then it looks nice. Okay. Yep, I agree. This is kind of jumping in, Urias. But I think one great thing is all of these notebooks are ready to go, so you can just go through and evaluate them on your own. Writing your own code might be a step harder, but seeing some good examples will hopefully be a good start. Okay, so you notice here that we have different data types. So here we have a mix of letters and numbers. Here we've got some numbers. And sometimes it's important to know what type of data our variables have. So here you can use this .dtypes. So T is the data set. And if I do .dtypes, then it will print out the type of data that we have. So now each of these rows here is the columns from above. So we have the product code, and we can see that that is an object. Object is kind of a catch-all for things like this, where it's a mix of letters and numbers. So then we have a bunch here that say int 64. So that means int means integer, and 64 is like 64 bits. So that just means how many decimal points you keep. which is not super relevant at this point. Basically, these are all integers. When you get to the temperature reading, these are floats. And a float means that it is a decimal value. So whereas an integer is just 1, 3, 24, anything like that, the temperature can be anything. So 24.72 or 1.5. So that's what a float means. So the one thing that you often have to handle yourself, and Pandas helps with this, is if you want Pandas to recognize that you have a date. Notice right now our date is just in terms of integers, so it isn't recognized as a date. Yes, you have a question? No? Okay. So what we want is a date time format, which you'll see in a second. So that's what I write here. So what we're going to do is we're going to convert these 3 columns. So they're all year, month, and day are each their own column up here, year, month, and day. But we're going to squish them together because we want Pandas to recognize all of them together as a date. We don't want it just to know that it's, month 1, day 1. Sorry, did you have a question for me?
Okay, that's good.
Okay, I don't think that was for me. So here is how we do that. So we do T of, and we use these square brackets when we want to access something inside of our data set. So in this case, we're actually creating a new variable called date time. So I'm creating a new variable here within our data set T. Because if we go back up, you can see there is no variable here that's called date time. And I'm using the Pandas function called toDateTime, and it can interpret year, month, and day. So all I have to do is type this line, evaluate that, and then if I print out the data set again and scroll all the way over, we see that I just created a new column called date time, and it recognizes all of these as a date. So now it says 2008, January 1st, 2008, January 2nd. So I'm just going to mute someone. So we just created a new column called date time. So we didn't get rid of the old one. You could also get rid of these if you want, but I just added a new one. And now if we check the type of data that we have, you can go down here and you can see that if you look at date time, it is a date time type. And S stands for nanoseconds. So that's actually how it saves your date time, is in terms of nanoseconds. But nanoseconds from a specific start time, which I actually forget. I think it's 1970 or something. So that's how it counts time. So now we have a column for time, for date and time. And that's great. So moving on, let's do a plot. So let's say we have this temperature data set and we just want to look at it and see how it looks over time. And our data set is such that we have, day, and then we have temperature, and new day, new temperature. So we're just going to plot the temperature. And I do that by using the matplotlib.pyplot library, which I loaded as PLT. And then I use the plot function. And then in the plot function, I just say, I want to plot the column from our data set that is the maximum temperature. So it's T, which is our data set, of these square brackets, and then the variable that I want to plot. And notice I have these this little like apostrophe quote thing. I need that here because this is interpreted as what's called a string. So it's a series of letters. So you need to have quotes around it. And we do that, and we get a plot. All right, Daniel has a question. How about if you had the date time variable rather and wanted to separate it into months? Yep, you can do that as well. Yeah.
Excuse me, when you plot this, how do we get the values in the x-axis?
Yeah,
Code?
good question. Just a second, let me cover Daniel's question first. So you can absolutely you can kind of manipulate these dates as much as you want. So here we use this toDateTime function. If you look up pandas and datetime, it has all sorts of functions. So I don't remember what it is offhand, but this one is toDateTime because we want to convert to datetime. But it has ones where you have something in terms of a date and you want to extract the month, and you can say, I forget what it is, but it's something like .month, and it will grab the month for you. So that's one really nice thing about pandas. Being able to interpret dates is very helpful. So on to your question, Kola Role. So yes, you had a good question here about what this x-axis is. It's just these numbers. It's actually, this is this is really not interesting at all. It's just the index. So basically, I at the beginning, I said we had 4,400 and something rows. This is just the number of the row, which is not anything physical. So it's not useful for us. So in the next one, so here I just said plot the variable I want to plot. Now I'm going to plot what I want on the x-axis first, and then on the y-axis. So I'm basically saying plot x comma y, where x is this new variable that I made, date time, and then y is the same thing that we had before. And we'll see what happens. So now it's the exact same plot, but now it shows up in terms of year, which is more meaningful for us. I hope that answered your question. Let me know if not. Okay, so now we have this nice plot. We can do a few things to it. So we can change the size of the figure in this top line here. And this is using fig size equals, and this is basically in inches. So if you were to save the figure to your computer, that's the size that it would be. So I just made it a bit bigger. This is much smaller. We have the same line where we plot the same data. And then I add some titles. So I add a title to the plot, and then I add an X label and a Y label. So I'll evaluate that. And now we can see I changed the size of the plot, and I made it longer because we have something that's going across this way. I labeled the y-axis to be in degrees Celsius. I labeled the x-axis to say year. Then I put a title in to say temperature in Canberra, Australia. And then I even put degrees Celsius again, which is a bit redundant. You can see how I did all of that up here. So again, I have to use these quotes because I'm doing a string. And I actually was a bit fancy here. I'll get to this in a moment, but I use something that's called Latex. You might be familiar with that, where I can create this nice little degree symbol in my title. So I'll cover that in just a moment. And font size means that I'm increasing the size of the text. So you notice that the title is bigger than some of these other labels, and that's because I said I want it to be bigger. Whereas I put the labels on the different axes to be 16. So this is how you can, you can imagine you could start to make interesting looking plots like this. Okay, so I mentioned this before, I used LaTeX. So if we go back up, we can see here that I have a $sign, then I have a bunch of stuff that looks kind of like gibberish, and then I have another $sign. So the $sign, if you put something between two $signs in Jupyter Notebook, it interprets it as LaTeX. So, and LaTeX is a typesetting language that allows you to make equations and symbols that look really nice. For instance, what you can see here. So here I'm just writing out, like if you want to take a mean, so an average, you can say the mean equals, and then you have this nice sum sign, you have a subscript I, and then you have T of I, and then you have it on a fraction over N. So you can do all of this with LaTeX. And you can, if you double click on this cell, you can see how I wrote this. And you can see that I have these double dollar signs. That means that I want it centered. If you did single dollar signs, it would just be on the left. Yes, Kay, do you have a question?
Yes, I do. Line 14 of your code.
Line 14.
Where we plotted.
This one?
Yes, that's right.
Mm-hmm.
I think for the x-axis, the variable t was equals to the year, month, and day, but
yep.
on the x-axis, I'm seeing only the years. How does that really? Where was the change?
Yes, that's a very good question. So what you're seeing here is Pandas interpreting. So because we have day, month, and year, if it labeled every single day, we wouldn't be able to read it. Even if we labeled every month, because we've got, 14 years, 12 years of data, we wouldn't really be able to see it. So it's labeling it with the year instead. If we zoom in, I believe that it would label the month. Let's see. If I do, let's see if this works. Well, I don't remember the syntax for it, but so I think if we just said plot 1 year, that it would label it in months instead. So it actually does some kind of smart interpretation for us to make the plots look nicer. One reason why it's really nice to use things like pandas. Yeah, sorry, I don't remember it offhand, so I won't do it right now. But yeah, that's how it's doing it. So it's not that it's just the year here. It still has all of that information of day and month. It's just not displaying it for us. Okay. So back down here. So this is how I make this LaTeX line. If you haven't really used LaTeX before, that's okay. You don't really have to worry about this, but it is really nice. I think this is one of the real benefits of using a notebook, in that you can have text and figures and code and equations all together in one document, which is really nice. So you can say, okay, this is the equation I'm about to solve, and then write it in code form. And then you don't have to try and read the code and say, what equation was I looking at? You can see the equation right now. So, so that's just a bit of an aside for those of you who use equations and know what LaTeX is and want to make pretty symbols. Okay. So because I just wrote this equation just for a test of the LaTeX, let's go ahead and take the mean. And we can do that very quickly with Python, with Pandas, where we take the variable that we want. So maximum temperature degrees C, and all I have to do is say dot mean with these parentheses, evaluate that, and it will tell me the mean temperature over the entire 12-year data set, which is apparently 21.36 degrees Celsius. So you can do these big calculations quite quickly in one line, which is quite nice. Okay, back to plotting. We'll add a few extra things here. So again, I specify the size of the figure, so make it a bit bigger. Here I'm adding something where I'm adding a color. And I'm adding this line here, which if we go back up to this plot, notice that we have some white space on the left and on the right. That happens by default. I usually don't want that white space. Sometimes it's nice. So here, if I use this plot.margins x equals 0, saying I want no margins on the x-axis, then you will see that there's no more white space on the left or on the right. And you'll also notice that it's orange, and that's because I put color equals dark orange here. You can put any color there are a lot of colors that it already knows. So, I mean, it knows things like blue. I think it knows like light blue. Let's see if that works. Yep. So you can try a few of those. You can find those by Googling pyplot colors, something like that. List of named colors. There we go. And here's a list of all of the named colors. So you can have fun. You can do sky blue or light sky blue or steel blue. So anyway, I won't go into that now, but you have your pick of colors so you can make your plots look really nice. All right, so throughout this notebook, I have a few challenges where the idea is that you can test your own knowledge and see what you can do. Would you all like me to go through these challenges with you today, or would you like to have a chance to try them on your own? Does anyone have any?
Try it first.
You want to try it first? How does everyone else feel? Do you want to leave these for later and you can go through it by yourself and try on your own? All right, if I don't get any answers, we'll just have to go with what Daniel said. So that was the only answer I got. Okay, so I'll skip the challenge for now. If you need any help, I'll help with this first one just really quickly. So for those of you who are quite new, I say copy and paste the above cell. That's going to be really useful throughout all of your coding in Jupyter. So if I highlight this cell here, I can go up to this menu and I can hover over the different buttons, and one of them says copy the selected cells. So I will click that once. Then if I click down here, I will paste a cell right below it by again going up to this menu in the top, and it's this clipboard icon, and I click paste. And now I've just copied this cell from here down below. That way I don't have to retype everything, and I can just change. So now I could change the color here to yellow. And then I can do that. So that's my one tip for you for here. So I kind of did this challenge for you, but yeah, just so you know how to do it. Okay, water break. Okay, so now we're going to do a bit of analysis on the data. So let's see, you type the word and enter. Nope, I don't know. Oh, I don't know what you're referring to. To copy and paste the cell, you click these things up here. But if I just want to change one thing, like the color, like I just want to change it to pink. Yeah, exactly. So I type the new thing and then I reevaluate the cell. So shift enter. Oops, shift enter. And then it will reevaluate. So you can reevaluate each cell as many times as you want. And you'll just notice that the number counts up so you can see how many times it's been evaluated. So this is the 21st cell to be evaluated. If I just reevaluate it, it'll be 22. And then I can reevaluate again, it'll be 23. So you can reevaluate the cells as many times as you want. And that's what's kind of nice about Jupyter, is you can run everything in one cell at a time instead of running an entire script together. You can also run the whole thing together. But yeah, don't be shy to just run a cell and see what happens. Okay, so
Hello, Paige.
Yes.
Hello, Paige.
yes.
Please, if you have my own personal data, which I want to analyze, and I have it in Excel format or in Word format,
Okay.
how do I import it into a Python library analysis with my own data that I've generated?
Yeah, okay. So I would probably recommend saving, I think you can save an Excel file as .csv. So you can do that, and then you just follow everything that we've done here with this, read the CSV file. I believe there is a library that reads Excel files as well.
Yes.
So that's another option. I forget if that's in Pandas.
Yes.
How to read. Yeah, cool, thanks. In Python. Yep, so here we go. How to import an Excel file into Python using Pandas. So what you would do is the exact same thing that we did here, except instead of using the read CSV, well, I assume it doesn't use the CSV. Yeah, so it uses a read Excel function here. So you'd say read Excel instead of read CSV. So it actually is almost identical to what we've been doing here. You just use a different function to load it in. But once it's loaded in, you can do all of the same things that we're doing here.
Okay. So then, so is working with Pandas different from what it is Anaconda?
So Anaconda is not separate from Pandas. So Pandas is actually included in Anaconda. So Anaconda is a distribution of Python and a bunch of libraries, including Pandas. So
yeah, good morning. There's something I should give you.
Sorry, I think that was for us. So Anaconda is something you will download Python using through Anaconda, but once you download it, then you will open up Jupyter Notebook through Anaconda, and then you will have a Jupyter Lab or a Jupyter Notebook that looks exactly like what we have here, and you can use all of the same libraries that we have here.
Okay.
And you can download more libraries if you find you need them. Yes, so Miniconda, so there's a question in the chat, can Miniconda be used in place of Anaconda? It can. So Miniconda is much smaller than Anaconda, so it's faster to download. It doesn't have all of the packages that you might want, so then you would just have to download them individually. So there's nothing wrong with that, but I suggest Anaconda just because you can kind of get most of the packages you want all together in one place. And it will install everything it'll kind of keep track of everything for you. But Miniconda is absolutely an option. Sorry, I'm getting some really bad feedback. Are others getting really bad feedback at the moment?
Yes.
Okay.
It's very bad.
I
Very,
can't seem to
very bad.
mute at the
Can
moment.
mute everybody.
I can't seem to mute individuals right now. Okay, that's better. Sorry about that. Still hearing. Okay, there's someone that is not allowing me to mute. The person who says user, if you cannot mute yourself, I might need to remove you from the call and you could try to join again. Sorry about that. Okay. Well, I don't hear any feedback at the moment. But if I hear it again, I'll probably have to remove that person. Sorry. This is just a reminder. If you aren't speaking, do try to mute, just so we don't have to handle this too many times. Okay. Great. So now we're going to do some data analysis. So this is a temperature data set. So one thing that is, quite of interest at the moment is climate change and how climate change is affecting different regions and different variables like temperature. So we might want to look at a trend, the temperature trend. So here we're going to, actually first we're going to detrend the data. So if you're interested in climate change, you might want the trend. If you're not interested in climate change, then you might want to get rid of the trend so that you don't have any of your data kind of messed up with a trend and you just want it to kind of flatten out. So we will detrend the signal using a new library, and it's called SciPy, which is like scientific Python. Now notice.
Kindly zoom so that we'll be able to see.
Oh, yes, sorry. Is that better? Sorry, I will try to remember that. So now you might notice that instead of saying import first, I'm saying from SciPy. So in this case, I'm saying from the library called SciPy, import one function called signal. So this is another way that you can import libraries. And in this case, I'm just importing one function from the library. So if you know you only need one function, you can do it this way. I could just have easily imported all of SciPy and then say SciPy.signal, their equivalent. But in this case, I knew I only wanted one function from it, so I just imported the one. So I'll evaluate that cell. And now I'm going to name a new data set because I don't want to overwrite my old one. I'm going to say now T detrended. Then I'm going to call the function signal that I just imported. And it has a function called detrend. And it's that easy. That's how I can detrend this variable. All right, now let's see what happens. Okay, so this is an error. I'm going to zoom out just a little bit. You can see here that it's this long error with a lot of garbage here that you might say, oh my gosh, I don't know what it means. That's okay. Doesn't really matter. Most of the time, what you want to look at is this last row right at the bottom, and it tells you what it is. And it says value error, array must not contain infs or nans. So what that's telling me is that this function detrend doesn't work if you have data set that has these nans, so they're not a number, which we do have, or if you had infs, which stands for infinities. So if you have really, really big numbers, Python and Pandas will just call it inf, so it'll be an infinity. So this detrend doesn't work if you have any of those data points. And so if you ever reading something and you don't know what it means, like something like this, copy this bottom line and paste it into Google, and Google can usually tell you. Someone will have asked this question, and you can see what the error means if you can't figure it out just by reading it. So, okay, oh no, we got an error message. But it's not actually a bad thing. As I said, errors tell you what you did wrong. So there's really nothing wrong at all with getting an error message. We just have to fix it. So here it's telling us, oh shoot, we know we had nans in our data set because we looked at that further up in the code, and then we did have nans. So we have to handle those somehow. So here, if we didn't know if our data set had any nans, we can use this function. So it's a Pandas function called isNA, which is kind of like isNan, on this variable. And so if we evaluate that, we see that it says true for several of these values and false for the last few. And of course, we don't see most of the rows because we have this dot, dot, dot in the middle. So true means that we have nans. So it's true if there is a nan. It's false if it's not a nan, if it's just a regular number. But what this tells us is that, yes, there are some values that are nans. So we have to figure out what to do with that. So we kind of use this fancy trick. So first of all, I'm going to copy, I'm going to make a copy. So I'm going to, within our original data set T, I'm going to call something called T detrend, just so I don't overwrite this data. So I'm just copying that. And now if we look at our data set again, if we go over to the right, we can see that we have this new column called T detrend. And now I'm going to use this line, which is a bit fancy. So basically I'm trying to say if there are ones that are nans, that's what, so this tilde actually is basically saying not. It's like a Boolean value kind of, it's like a logical not, which isn't, it's okay if you don't quite know what that is. For now, you can just evaluate this line as is. And now I'm going to detrend this where I'm saying the ones that are not nans. So I want you to evaluate all the ones that are not nans, basically. Cool. Then I have this statement here that's actually no longer true, but it says you may have gotten a warning after running the above cell. and we didn't. And that's because we imported the warnings package at the beginning, and it said ignore all warnings. So now we don't have these warnings.
Excuse me,
Yes.
why do we need to detrend? Why do we need to detrend?
So this
What
is
is
just
the
a sample if we're trying to analyze some data at the moment. So we have temperature, and maybe I'm just interested in the seasonal cycle, but not in a trend over 12 years. So, you know, you'll have over 12 years, you may have some sort of trend that like if gradually goes up or goes down. Sometimes when you're doing analysis, you don't want those trends and you want to get rid of it. So this is just, we're in a hypothetical world where we're doing this analysis and we want to get rid of that trend. So that's why we're doing it. You might want to do this, for instance, if you do any spectral analysis. If you're familiar with Fourier analysis, then you will want to detrend. So that's quite common. So it's something that ends up happening quite a bit. So this is just an example case.
Hello.
Yes.
Hello, Paige. Yes. So when you were checking for the NAs, assuming that the first 5 rows of the temperature, it was also false because of the way the answer to the logical statement is printed. So if assuming you had for the rows 0, 1 to 4, it was all false, and then the ones below 2 are all false. How do you see if there's any in there?
Yeah, great question. So I think there is something, that is a good question I should have included. Pandas, I think there might be something like a count. So you could count how many, yeah. I probably should have included that. So this is count non-NA cells for each column or row. So you could do this to find how many values are not nans, and you could compare it to the full number of rows and see if they're different, then it means that you do have some nans.
Okay.
Yeah, that's a really good point. But yeah, that's probably the quickest way. When you have so many rows, you don't want to have to look through all of them. But if you just do a count of, so here's counting the non-NA. You can also kind of count how many trues and how many falses there are in a data set or in a variable. So yeah, you can use count to do that. So that's a good point. I think that's something that like I should have included. So if you're going through and you're like, oh, there, I want to take a note here. You could zoom out, add a cell. I'm going to type M to make it markdown, which is text. And I could say like note to self, I should try the .count function to count number of non-NANs. Or something like this. And then you have a little note to yourself, and you can save these notebooks, but you know, you can do anything like this where you can add any cells, write notes to yourself, or even as we're going through, if you're like, oh, I didn't understand this line. Oh, but Paige just said what that means, and I need to write that down so I remember. You can do all of that. You can, these are kind of your own notebooks now, so you can do whatever you'd like with them. Cool. We could try and use the pd.count. Let's see. Forget the syntax. Let's see if this will work. Live demos are always iffy if I remember what I'm doing. Nope, it does not have count. Data frame.count. Okay, so that means we want to do t.count. Okay, there we go. So that's how I would do it. So I'd say t.count, or this t and of the specific variable that I want, .count, and it tells me there are 4,137 values that are not nans. But when I look here at the full length, it's 4,404. So I know that the difference between the two is how many nans there are. And you noticed what I first tried was doing pd.count count. So saying I want to use the count function in Pandas, and it gave me an error and it said there's no function in Pandas called count. So I went back over here. It actually says pandas dot data frame dot count. And this, what I've been calling our data set, is called a data frame in Pandas. And so I realized that I need to write data frame and then do dot count. So that's what that means. So hopefully that was helpful. Yeah, cool. So very good questions. Okay, now let's plot the original time series and the detrended time series in subplots. So this means that we have one plot on top of the other. And I just do that here by saying PLT, so it's pyplot dot subplot. And then 211 means that the first number is how many rows I want of plots. So here I say 2 because I want 2 rows, so one graph on top of the other. And the second one is how many columns, and I just want 1. And then 1 meaning this is in position 1, and down here I say 212 because it's position 2. So that's how you make a subplot. If you're making figures for a paper or something, at least a lot of the journals that I am familiar with want you to have subplots instead of having individual plots within one figure. So it's really nice to know how to do a subplot. Okay, so now we see that they look almost identical. But if you notice, the y-axis values have changed. So in the detrended, they're now centered around 0. And that's because we took out the trend, but we took out the mean as well. So it got lowered down. But other than that, they look very similar. Okay, so here's another challenge. And unless anyone speaks up, I will let you try that on your own. And as always, the Slack channel is there to ask any questions like this, if you have trouble with any of these. Okay.
Hello?
Yes.
Paige, please, could you come again with the difference between the two plots?
So these two plots are, well, so what we did is, I think what we do next will actually help explain. What we did was basically fit a line to the data and then subtract that out. And so in this top one, this is the original time series. The bottom one is now, the mean has been taken out, so it's centered around 0.
Okay.
But it
so those
also,
below and above.
What's that?
I was just saying that values below and above the mean.
Yes, right. Yeah. So
like
exactly.
An anomaly,
yes.
kind
yeah.
of.
Yeah. Yeah.
Okay.
Exactly. Yes. So this is like an
Okay.
anomalous thing, but we also took out like a trend that if there was any trend in the data, which we'll see it was also removed. So we took out a mean and we took out like a linear trend, which will become a bit clearer in the next bit, because here we took out a trend and the mean. What if we are actually interested in the trend itself? So over the last 12 years, is the temperature increasing or decreasing or staying the same in Canberra, basically? So if I evaluate this cell, this is just the trend with no data. And we can see that over the 12 years, there is an increase in the average temperature. Average maximum temperature in Canberra, there has been an increase. And we fit a line to it, so it's not, that's why it looks so linear. But overall, there is a line that is increasing, which may or may not have to do with climate change, but probably does. Okay, there's a question here. How to plot the detrended and date time on the same figure? So I think you mean, so the date time is the x-axis. But yes, to plot the two together in the same figure is this challenge number 2. Did you want me to go? I'm happy to go through that if you want. But yes, plotting with a different color is definitely recommended. So you can go back up and see how we handled color, where we just said comma color equals within the plot function. So you can do that here. You can do that within both and have them be different colors. So I think that was your question. How to plot detrended time series and original on the same figure with different color. Yeah, so that is literally the challenge too. So that's a good question. What you'll need to do there is, as I said, you can change the color like I just mentioned, but to put them on the same plot, you want to get rid of the subplot. So subplot means that you have many plots within one figure. You want to get rid of the subplots if you want them on the same axis. So you'd have to delete these two lines where I say plot.subplot, and then they will be plotted on the same axis. I hope that was helpful. That was basically challenge 2. Okay, so here's the trend. Here, this challenge is to put, I'm forgetting which challenge is which. So this one is also putting the trend line and the temperature data set on the same axis. So this would be the same thing. You could just copy this text here because that plots the trend, the line, and you could kind of merge it with some of the lines of code that we have up here so that you can plot them on the same line so that you have the data set and you have the line together. Let me know if you want me to go through these. Otherwise, I'm still going to let you do these challenges on your own. And there is a Python Q&A next Wednesday. So in 1 week from today, and that is a time to bring any of these kind of questions. Oh yeah, sorry. Sorry, I'll try to remember that. But so the Q&A is a good time to ask these questions, but these kind of questions as well, these are really great for posting in Slack so that you don't have to wait a week to ask these questions. I also have more tutorials tomorrow and Friday. So and you can ask these questions there, although we'll be going through different notebooks. Okay. So now I call it fancy plotting. So just doing some more plot, like putting different data sets together on the same plot. So here we're going to load in a new data set that I'm calling AQI, and that's for air quality index. So I'm now looking at the quality of air, so air quality in Canberra. And I'm doing that because I don't know if any of you heard in the news like a year and a half ago now, but we had really bad fires in Australia, forest fires. And there was a lot of smoke in the air, and certain parts of Australia, of which Canberra was one of the worst, we had really bad smoke. And so we had really poor quality air. Curtis, did you have a question? Curtis, I see your hand is raised.
Yeah.
Yep.
Hello.
Hi.
Can we have access? Can we get access to the data that you're using for? Can we get access to them?
Sorry, you're a bit quiet. How do we access the data that I'm using?
Yes, please.
Yeah, so that's, we're just reading in data from the shared folder here. So you should start in your, up in the upper left here, you start in the COESSING2020, oops, trying to scroll around, 2021 hub folder. You can click on this folder icon to go to your home, and you should see the shared folder. And that's where all of the data is for these labs. With the exception that there's some cloud data that we use that's not stored here, and that's stored on the cloud. So that's where we're reading in all of this data from. And you can see here that I use this ... which as Daniel asked before, that means go back one folder and then go into the shared folder. And then I'm loading this air quality data. So, so I'm loading this air quality data, and I kind of did this like a year and a half ago because I was curious to see how I was pretty new to Canberra, and I was curious how much the air quality was different from previous years. So we're loading in this air quality data. I use this .head again to view the first 5 rows. And here we have a completely different set of column names. So we have name, civic. So this is just like the name of where the data was taken, I think. We have some GPS location if we wanted to figure that out. Here we have a date time. So notice this is already in date time. So we have a date and we also have a time. So this is an hourly data here. And then we have a bunch of other measurements. And the one that I'm going to look at today is PM 2.5. So this is the really small, it's particulate matter of 2.5 microns or less, I think. So those are the particulates from smoke that are particularly dangerous. And so that's what I'm going to plot, because that's what we all kind of cared about. Then we actually have a separate date and a separate time column. That's interesting. So anyway, all the data that you have everything will be kind of organized differently. So it's kind of nice to take a look. Okay, so let's look at our date times again and see if they're the right type. So I do this .dtypes again. And we can see here that the date time column, it actually had the date and the time together, but it's in the form of an object, and we still want it in terms of a pandas date time. So we do the same thing that we did before, where we use the toDate time on this column called date time, and run that. That's taking a little while. We can see that little star there. Great. Now, if I rerun this dtypes up above, we can see that the date time is now a date time type. Okay, so we can take another look. And actually, this is a typo that I noticed. So if we do, we can use .head, and it's the same thing that we saw before. And it looks like the times are in order, or like the date time is in order. If we do .tail, so .tail is the same thing as .head, but it shows you the last 5 rows instead of the first 5. And we evaluate that, then we see that these dates are actually not in order. So we've got like December 21st, 2019 and July 7th, 2019. So they're not quite in order. So we have to do a bit of sorting, which is quite common with data. And you can use this sort values. And here, because it recognizes date time, we can just say sort by date time, ascending equals true. So we want to start with the oldest and go to the newest. And so that's all we have to do. Now we can rerun this tail. So this cell up here, the .tail. And we can now see that everything appears to be in order. Okay, take a little water break. So now we can create a figure. And this one is quite a bit more involved than some of the others. And you'll see why. So I'm going to, so here, well, first of all, we see that we start with the same. Here we're using plot, we're actually using .subplots. And that's because what I want to do here is put 2 variables on the same set of axes, but they actually have different values. So I want to put temperature and air quality on the same axis. So I'm going to have 2 different y-axes, one that has temperature labeled and one that has the air quality index labeled. So I do this similar thing, but here I say I'm actually defining this. I'm basically giving a name to our figure. And this, you can kind of just take this as is for now, and you can feel free to read up on the details, but basically I can say figure comma axis. That's what these stand for. And then on the first axis, I want to plot what I had before. So this is our original data set, the temperature. Here I'm going to put a label. So I want to say the label is maximum daily temperature. I can put an alpha here. You'll see what that means. So I might just delete that for now. We'll do that in the next plot. So we don't need to talk about that. And then for this first axis, I'll set the Y label to be temperature and setting the label, setting the size of the labels on the Y-axis to be size 12. So anyway, I'm kind of adding a lot of these details, which we don't have to go into now, but these can be an example if you want to change any of these aspects of your plot. So then the real fancy trick here is this one. So whereas here I had AX being our first axis, now I'm defining a new axis called AX2, and I'm making it a twin. So I'm basically copying the first axis. So I want it to be an essential copy of the first axis, but I'm going to plot a different thing on this axis, and it's going to be this PM 2.5 value. And the label will be concentration of PM 2.5 particles. And again, I set some labels and parameters. The set ylim lets you set the how low and how high you want your axis to go, your y-axis. I'm going to comment this out for now because we'll see that again later as well. And then the xlim is the same as well, setting the limits in the x-axis. So there's a little bit of fanciness here, which I won't go into, but it is here so you can look at it and hopefully learn from it. So if I evaluate that, we now have this plot. So this bit should look familiar. This is the temperature data that we used before. You'll notice that I zoomed in instead to these values between 2015 and 2020, just so that we can better see this curve. And also because our air quality data didn't start until 2015. And so this line here is the air quality data. And we see that on the right side is where we have the air quality PM 2.5 concentration labels, whereas as usual on the left side, we have the temperature. So we have them on the same plot and we have these different scales. Now we can make them look a bit nicer by adding in some color and other touches. So you could do something like this. So now I put the temperature in red and I labeled the temperature labels to make that much clearer. And the PM 2.5 concentration is in black, and so is their label. I also included this dashed line here. This is what is considered to be the healthy air quality. So these are just some things that you can do with your plots. I think I do one more rendition, which is here. So now you'll see that instead of it being a bright red, it's more of a dull red. And that is because I use this alpha here. So I say alpha equals 0.5. If alpha equals 1, then you have your full color. But if alpha equals 0, you will see nothing. And in between, you have this transparency sliding bar. So it's just a fancy way. Sometimes if you have overlapping lines, like we do a little bit here, you kind of want one to be slightly transparent so you can see through to the other one. So you'd use alpha to do that. I also filled in the space underneath the air quality, the PM 2.5 concentration with this gray. And I use this fill between function to do that. So I'm basically saying fill between, well, the x-axis I still want to be this date time, then fill between 0 and the value. And notice that I put alpha equals 0.3, so it comes out quite gray. So yeah, so that's just an example of how to make some types of plots. I kind of flew through a lot of that. And as I said, a lot of this is having the examples there so you can look through it. I will show one more thing before I stop for questions. So if this is a plot that you want, say, in a paper or in a presentation, you can save this figure. So I'm going to type over here. I'm going to say plt.savefig, parentheses. And then I'm just going to name the figure what I want. So this is Canberra temp PM 25, something like that, .png. You can use different extensions. You can use JPEG as well as many others. I tend to like PNG the best. And if you run this, so we run it again, we get the plot again. And now if I go back into our 2021 hub, you can see that there is a new file that was just modified seconds ago, and it's called Canberra temp pm25.png. So that's how you can save your figures. And as a reminder, you can always right click and download, and then it will download to your local computer. So that's kind of how I do my research. I do my research on a Jupyter Hub, make figures, and then download them to my computer. Okay, are there any questions about all of this? Did you have to manually go into the data to find the index for the date time variable? Yes, so some of this is probably not, there's probably slightly better ways to do some of this. That's a good challenge. If you find better ways to do this, please let me know, share them in Slack. So you mean for the date time variable? Yes.
I think the code above.
Yes, 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 yes. Yep. Yeah. So here, yes. So I skipped over this line because I don't think this is the best way to do it, but it was what I figured out in the amount of time. So yeah, I searched for the index that I needed to have it start here in this like 2015. And I can't remember why I needed to do that, but it was definitely not the best way to do it. So, but yeah, I was able to just find an index that I wanted to start from and did that. So yeah, that's a good question. Yeah, there's probably a better way. You should figure it out and tell me.
Okay.
So that's a lot of like coding, as you can see. I've been coding for a while, but like there's still a lot that I don't know and that I'm learning.
Excuse me. Okay.
And yep, your eyes, yes.
Yes.
Go ahead.
I've been following, but like I said before, some of us who've been new or are quite new to programming language, because I didn't have the opportunity to also write MATLAB. So even because I mean, most of what you explained, I did it before during my graduate studies, but that was for a very short time. And since then, I haven't been really working because my kind of work doesn't really center around data analysis. That was when I was in school, but since I graduated and now work for some time, I actually used to do a lot of data analysis. But then of the last 6 years, I haven't really been working with any form of data. So I mean, so what I wanted to understand is that if you have to run plot in this kind of programming language, you have to write the language and you enter to develop the plot, for example. I mean, I've been following, but I still wanted, because your demonstration, the font size of the writing quite small, and just following your explanation, but I still find it a little difficult to understand the steps and procedures. So what I wanted to know basically is that if we had to plot value, for example, it means that we just write the language and enter, then we generate the plot or something.
Yeah. Yeah, and I recognize a lot of this might be hard to follow if you're new. Again, I still think it's nice to have these examples here. And I'm trying to tailor it to different, levels. So if we go back to the top here, so if you can figure out how to load your data, so whether that's using read CSV or read Excel, then you can read your data in. You can just do something like this, plt.plot, and you pick one of the variables that you have in your data set, and you can just plot things like this. So some of these basic features, hopefully this is helpful for you to see. But you can just kind of do this quite quickly once you load your data. So I don't know if that quite answers your question.
First of all, how do you go about loading the data into the? So are these things all explained in the write-out in the Jupyter in the Python? Are they write-out all well explained, or you have to demonstrate? And so, because I was following the first what is it? The first exercise yesterday. So once you go through the manual you have, because I was a bit lost until when I have to go back to the YouTube video and started catching a few things. So I want to know if this is the same way you, especially for beginner, where you have to go through the literature and you see exactly what are the steps. Will you be able to catch up with some of the things you have been explaining?
So yeah, the idea is that hopefully you can, start to figure these things out, like from the introductory Jupyter walkthrough, which we did the other day.
Sure.
Yeah, but there are likely some big gaps, kind of jumps. So I think it partly depends on how you want to learn. So I think it is a very good idea to go to some of those resources that I mentioned on the COESSING page for kind of how to start learning Python. And doing some of these beginner things can be quite helpful just to understand how everything works. But I actually do think that it can be really useful to take something like this notebook here, and maybe you make a copy of it. So you can copy this notebook by going to File, Save Notebook As, and then you can rename it. So you could name it like data analysis or whatever. You can name it whatever you want, and then it'll save a copy, and you can then you still have the original notebook, but then you can start playing with it, and you could try to replace lines. So instead of having to write everything from scratch, you could say, oh, I have a CSV file as well. It has a different name. It's probably stored somewhere else if this is on your local computer. And you can try loading it in and see what happens, and try to copy these steps. So even if you don't understand exactly how everything works, I think that can still be a really good way to learn programming. And as I said, you'll get errors, and that's also fine because the errors can help you learn.
So the resource center in the COESSING website explains some of these steps, right?
Yeah. So sorry, maybe we're not quite understanding the question, but on the COESSING,
on the COESSING website, if I have to go through understanding some of these steps, I can find the resources there, right?
Yeah, hopefully. So that's, if you go to the resources page, that's where we are here on the COESSING website. There are some here. So there's a starter for this using realpython.com. There are some text tutorials that I have. I'm still getting feedback again. Oops. And so here I'm saying this is introductory to Jupyter Notebook in Python. Sorry, I'm still getting weird feedback. There are some videos of how to use these. The other thing I really recommend is with all of these, and I think I put this at the top of some of these. A lot of the packages have really good walkthroughs. Let me see, did I put it? No, so I didn't put anything here. Okay, so what I recommend is, for instance, Pandas, I think is going to be a very popular one. If you search Pandas for the library, they will have some examples. Maybe you could say getting started, and you can go through some of those. So here it tells you how to install it locally if you need to. It should already come with Anaconda if you do it that way. And then you can do here straight to the tutorial. What kind of data does Pandas handle? And you can click on that, and it will kind of walk you through a lot of the basics of this library.
Panda, what's the website? Panda what?
Pandas.pydata.org. I can't zoom in on that, sorry. So I'll copy it and put it in the chat.
Yeah, sure.
Oops. Pandas website. And a lot of the libraries have really nice resources like this. If you go into the intro Xarray and Dask one, I have a couple here as well. So Xarray fundamentals, these are actually, so you can Google any of the Xarray and Dask are two different libraries that we haven't been using today. But just as an example, you can Google both of them. They both have tutorials on their web pages as well. These are some really nice links through actually my postdoc advisor. He did a research computing class a couple years ago, and he has a lot of things really nicely laid out for kind of teaching specific ocean climate related Python. It may assume a bit of knowledge, but I don't think it assumes much Python knowledge. So, and I don't know if I've added those resources here. I don't think I have. So yeah, that's a good note. I will try and I'll add more to these resources. I know it's kind of hard. That's why I tried to put some notes into here of what these are. So you have some text tutorials, you have some videos, but I can try and make sure that I add more of these tutorial links on the Coessing resources page. So that's where you should go to have more resources. And if you find some good ones that you found really helpful, please message them through to me or post them on Slack so others can see. And I will make sure that we add them to the resources page.
Okay, thank you.
Okay, thank you so much.
Yeah, okay. Are there any other questions about any of this?
Not yet, no.
Okay, where did we get to? Oh, that's the wrong one.
Hello, Paige.
Yeah.
Yeah, in loading the data, what if I'm I want to load my data from a website? Let's say we already have data in CSV, but what if I want to load it from a website where the data is being stored? How do I go about that?
Yeah, that's a good question. So it depends how it's stored. You may, I mean, one option is to download it to your local computer. Yeah, I don't have too much experience with loading directly from websites. There are a few different ways to do it. Sometimes you can use something called wget. This is, if you go into the labs from last year, the Cartopy tutorial, as well as I think one of the other ones, uses wget to get some data from a server. I'll try and pull that up. Okay. Oops. I lost it. So this is a PDF of last year's Cartopy tutorial. This year we'll be using data from the cloud. But you can use this line here. Oops, I did not want that to happen. Where you use wget, and it's a way to grab data from FTP servers. I have to admit, I'm not an expert at this. I haven't used it very often, and it kind of depends on how the data is being stored. But wget is one way to do it. The other thing I would say is if there is data that you have from a website, it's possible, or I guess I might hope that they have instructions for how to access it. So I have sometimes come across data and it says, here is how you would access it using wget. And it has a little line of code for me, so you can use that.
Alright.
But yeah, that's, sorry if that's maybe not the most helpful. That's as good as I can do.
No, it's all right. I got.
Okay, any other questions? So we have about 15 more minutes. I could keep going here. I make some bar charts down below, but that also might be good for you to go through on your own. I'm not sure this is just kind of showing how to do a bar chart.
Is it also possible to create a figure with map from this program language?
Yes, so you can just, so none of the data that I have here are in map form, but you can just use pyplot, and if your data is in the form of a map, it will kind of look like a map. But if you want to make maps, definitely attend the Monday tutorial on Cartopy. So Cartopy is the library that helps you make nice maps with different projections. And my colleague, whose name is Josue, he's really great. He's the one to ask. He's the guru of visualizations, and he's really great with Python in general. So, so I really encourage you to go to that. Next Monday, what is it? Next Monday, 9 to 10 a.m.
Okay.
Yeah, any other questions about anything here? I'm also open. It's really nice to hear all of your questions to know what you want to learn more about. But if you'd really like a session on something specific, let me know. We could maybe add another session next week, or find have a Slack discussion about any topic that you think you need the most help with. So potentially something on beginning Python. But yeah, any feedback is really welcome. I'd like to hear it.
Yes.
Okay, nothing else? No, nothing anyone wants to do here? So tomorrow and Friday, I'll be going through this Echo tutorial, or this Echo notebook here. I also am hoping to have another notebook with some Echo data analysis. Hopefully that will be finished by tomorrow's session. But I think I will start by going through Xarray and Dask tomorrow, which is just kind of an introduction to these two libraries that are very widely used in the ocean and climate modeling communities, and really helpful for large multidimensional data sets. Yeah. And for those of you who are interested in using or in coming to the Echo tutorials, I suggest you watch the, so all of these dark blue things here are Echo sessions. And if you'll notice, we actually added a new one next Tuesday, because one was yesterday. And if we click there, we can see all of the Echo information. I suggest you watch this pre-recorded lecture. It tells you a bit about what Echo is, and that will be good background just so that you know what it's kind of a mix of an ocean model and of observations, called an ocean state estimate. And so it gives you a bit of background, and then you can come in with a bit more knowledge. And I do highly recommend the Q&A sessions with Dimitri. So one was yesterday, so you missed that one, but next week. And also, I don't know if Joseph is still on, but Joseph is giving an ocean modeling session later today. So from 11:30 to 12:30, and the same time next week. And these are all very related. So if you're really interested in anything, ocean modeling, Echo, all of that, I highly recommend those sessions. I think they're going to be really, really helpful.
Yeah. So Paige, I'm still here.
Great.
Yeah. So yeah, there'll be modeling Q&A in about maybe 40 minutes or so. 11:30 to yes.
Today?
Yes.
Okay.
Yep, today is the 28th.
So I wrote on the I don't know if people have been following what is on Slack. I posted a few things on Slack. So you could I mean, you should watch the videos and maybe the slides and then come with questions. Once we know what people are interested in and their questions, then next week we can go into some detail about maybe setting up a model and then maybe running test cases and all of that. So yes, you can come around and then pose some questions. Okay, thanks, thanks, Paige. This is a great great notebooks actually. I'm learning a lot from Pandas. I haven't used Pandas a lot, but I'm learning a lot from your notebooks.
Yeah, so cool. I actually don't use Pandas much myself, but I think it is one of the most used Python libraries.
Yeah.
So almost all data scientists use it. So, when you have tabular data, so data in table form, it's really handy.
Yeah, I mean, recently I had to, I wrote a simple tutorial for one of my students. So that's when I started to learn it myself. We got some data in a published paper and we want him to use it to compare the data to our model.
Okay.
Some kind of, so he had to learn how to use Pandas. So that's nice. I've learned a lot of new things.
Yeah, great.
Thank you.
And you'd be a great resource as well. Joseph can certainly answer a lot of questions you have about programming, and maybe now about Pandas as well. So, so yeah, thanks, Joseph, for your help. Sure. Okay, I think I will stop sharing the screen. Is anyone interested in doing another photo, or are we all photoed out? I've been doing a lot of screenshots recently.
Let's do one.
All right. Joseph is on board. All right, so if you want to turn on your video, then I will get rid of the chat, make this full screen. I'll take another screenshot of our tutorial session. Okay.
You see me?
Yes, we can see you. Okay. Does everyone have their video on who wants it on? You have about 5 seconds to turn it on, and then I'm going to take a photo.
Okay.
Okay, we've got a few more here. All right.
Yes.
Anyone else?
Good.
All right. Okay.
Cheers.
Ready? 3, 2, 1.
Ciao.
All right. Looks great.
All right.
Good to see
So
all
you
of
can
you.
share it. You can share the picture with us on the Slack.
Yeah, I'll share it in Slack and I'll try and post it to the website soon as well. No one else has given me any photos, which means I get to post all of my photos. So all of you will get to be featured.
Right.
So bye.
All right.
Yeah, thank you all for the questions and thank you.
Yeah. I will be coming for is it XRA tomorrow? XRA?
Yeah, so on the schedule, it has Echo. I have Echo for the next 2 sessions. And my guess is they will be similar again. So you only need to go to one. But I'll start with X-ray because we will use X-ray to do the echo analysis. So
right. Okay.
Yeah, and some Dask as well.
Yeah, I'll show the in for that.
Yeah, great. Okay.
All right. Bye.
Bye, Joseph.
All right, bye. Bye.
We can make a request. Then why the platform?